and so are you.
Hello, Internet.
Hello. Yes.
Welcome to another Q&A Live.
We are edge-ish, I guess.
We're edgy.
Yeah, we're edgy. Yeah, we're sitting on the edge overlooking the city here. This is RJ.
This is William.
What do you do here?
Support, Q&A, like answering questions and helping people out. And you, William?
So if you call the phone number for Edge and you need, why is my thing not working the way I think it should work? You're the person who answers those questions.
Most likely you would get me if I'm on the phone. Maybe not right now, but you would get me.
Mostly people call support because something's not working the way they think it should. Do you get any support calls that are like happy, like, hey, you're awesome?
Sometimes we get positive feedback, like the coins that we've added, Raven coin. Yeah, we'll get some positive feedback.
Okay, so it's
not all angry users. Yeah, thank God.
Well, you'd hope that most people aren't angry. They're just like, I just need you to fix whatever I need to.
They're just a little lost.
Yeah. I'm a coder, so I write the app. I write the programs that do the things.
Yeah,
here.
you make magic happen.
Yeah. So if our wallets needs new features, you call me and I'll put them in my schedule.
Which is a huge list.
Yeah, there are so many features that people have come to us and say, we want this, we want that, and we've just got to find how to prioritize and get everything out in a reasonable manner. So
right, or get an army of Williams.
Yeah, if I had a cloning machine, and yeah.
Yeah. Okay, so let's see. First thing to talk about, maybe we could talk about the rapid swing.
In price?
People like talking about it.
Bitcoin price. Yeah, so it was rather exciting. We were stable at 10,000 for what felt like a month and a half. And then it crashed back down. I say crashed to 7,000-ish?
Yeah, like 7.5.
So it's like a 30% drop.
Right.
Now, for a stock market, that would be like catastrophe, right?
Yeah, like some kind of huge event would have happened in the news.
But for crypto, it's like a 30% drop. That's fine, whatever.
Yeah, it's like normal.
It happens all the time, whatever.
Yeah.
And now we're back up to about 8,500.
85, 86.
It's pretty funny. This morning, we were like, oh, it's 8,500. And Peter, who's sitting over here, you can't see him, he's off screen. He's like,
oh, no, it's already 11,000.
We were like, what? 11,000? What exchange are you looking at? He was looking at it in Canadian dollars.
Yeah.
So.
Yeah, oops.
So anyway, yeah, it goes up, it goes down. What can we say? I mean, there's a lot of reasons that might happen, but fundamentally, it's more people buying than selling, or more people selling than buying.
Right. That's the true indicator of the price. But
don't ask us to wizard that. We don't know what that means.
Yeah.
But some things in the news may or may not have contributed to this price swing.
They may have had an effect. So another one is the volume of backed is at all-time highs. The 18th million Bitcoin.
So backed, what is backed?
Backed is, what is that? The derivatives?
So I think
futures.
Yeah, it allows you to buy future Bitcoins.
Yeah, at a set price.
Right.
It's kind of like a gamble.
So futures markets are weird. If I explain them on this podcast, I know I've explained them on this podcast, but basically the idea is if you're selling wheat or oil, you could say, well, I haven't mined the oil or grown the wheat yet, but I'm going to sell it December wheat now, earlier before December, because I know the harvest is going to be there and I can sell it then.
Right.
So you'll get a price now that you can plan your harvest around,
right.
And then other people are going to take the risk that maybe wheat will be more valuable and they'll make more money off of the price being higher in December. So
it's still like a gamble play.
Yeah, futures markets work for commodities. Using them for cryptos and currencies is weird, but it's certainly a valid way to use a futures, and so backed is a future on Bitcoin.
Right.
So if it's at an all-time high, people are speculating that they want to buy future Bitcoin for some reason.
Right, and it's good. There's more investors jumping in on it. So new highs on the activity there. Yeah, more traders coming into Bitcoin crypto space. 18
million Bitcoins mined. So the total supply of Bitcoin is supposed to be 21 million.
Yeah, and so we're at 18 million. What is that, like 80 something percent?
So there's 3 million more to go. 3 out of 21. 21 about 15% short of the all-time. So 95% of all Bitcoin that will ever be created have been created at this point.
Right, but by 2020 or 2024, because of the halving and the amount of Bitcoins being mined will become like 90-something%.
So the amount of Bitcoin is always that is being produced by the mining process is always going down, and because of the way that goes, you get most of the Bitcoin up front, and then just smaller and smaller trickles as time goes on. So the last Bitcoin won't be mined until
2140.
2140, so that's like hundreds of years from now.
Yeah.
But
it'll take like the last 100 years
to mine the last.
But
it'll be such a small trickle of Bitcoin coming out at that time, it's almost irrelevant.
Right.
So we're already kind of like most of the Bitcoin that ever is going to exist is existing now.
Yeah. And let's see.
So that's Libra Facebook. So
Yeah, so they had like this trial hearing or talk with the government, and they were mostly under attack with like how Libra and other companies that are dropping out from backing Libra. So that was kind of interesting. So maybe that had an effect in the initial price drop or the price increase.
Well,
Who
I mean,
knows?
okay, so I think Libra is bad for Bitcoin in terms of if Facebook succeeds in creating, I don't know, it could be bad or good. If Facebook succeeds in creating a very large, very popular cryptocurrency,
Yeah.
then people might feel, oh, I've invested in cryptocurrency via buying the Libra. Why do I need Bitcoin? Because then you'd have a currency that can cross borders and be traceable
But
and
not
on the
truly
blockchain.
cross borders.
But
To the common.
Facebook's controlling it.
Yeah.
So you don't have the actual things that we care about Bitcoin for, like the censorship resistance
Yeah.
and the finite supply and all that sort of thing. Like the fact that Bitcoin's going to have a limited supply of 21 million and we're 85% of the way there already.
Right.
That's something that's sound money, right? You don't have like people being able to just print money out of thin air. With Libra, they could do that.
Yeah.
They could decide to repeg it or do whatever they need to do. So the shenanigans that are possible with Libra aren't possible with Bitcoin, which makes Bitcoin a much better currency.
Right.
But if it
Sound
has
money.
all the cool properties of being able to instant send and all these other things that Bitcoin also brings to the table, then people might not get the real things like sound money, but they'll get all the side benefits, the cheap, it's like getting the sugar rush of eating an apple without all the nutrients that come from the apple.
That's a good analogy.
So I don't know if I really like Facebook's Libra project. So
But
more-
on the good side, it's kind of like AOL, where people jump in on the easy
AOL,
internet.
and then that gets them onto the real internet.
Yeah, then they get on the real internet, so they're kind of trained, and at least they touch base on that from there.
So I don't know how I feel about it, but it looks like more and more companies are deciding that it's just going to be Facebook. It's not going to be this consortium of different companies.
Yeah,
So we'll see where that goes.
and if that happens, then it goes from governments and now it's private companies competing to create money.
Yeah.
Yeah, so that'll be interesting.
And then the other thing is happening is the Fed is what's up with the Fed?
Oh, negative interest rates also, I think,
So-
coming into play in the future.
So people have talked about negative interest rates, and I know that some countries in Europe have that as a
Yeah,
real thing.
they have that already.
Yeah.
Yeah.
Here in the United States, I don't think we've
It's been talked about.
quite got there yet.
Yeah, it's almost
But
there.
one of the things that's been happening is the Fed's so there's something called the overnight lending
Oh,
rate.
yeah, they printed like what, some billions of dollars overnight the next 3 days.
So at the end of the day, every bank needs to make sure they have enough money in their vaults to match what people think that they own, right? Or at least
Right.
enough assets like loans that would count as money towards that balance. So at the end of the day, banks need to settle up and make sure they're good.
Yeah.
And if they aren't good, then they can usually go get a loan overnight to make up for the difference and kind of balance things out.
Mm-hmm.
That market froze up. We're not quite sure why it froze up, but it just froze up. Banks
Yeah.
would go to the window and they say, I need to get a loan. And they're like, we don't have any money to loan you.
Yeah, they're just dried up.
It just dried up.
Yeah.
And so that would freeze up the banking system and cause collapse if that didn't get solved. So
Yeah.
the Federal Reserve stepped in and said, if you can't get an overnight loan, we'll make an overnight loan for you.
Right.
And so they've been printing money like mad and loaning it out in these overnight things.
Yeah, I even read like it was as high as the entire Bitcoin market cap.
Yeah,
over those
has been
3 or 4
printed.
days. Yeah.
Yeah. So that's another thing. It's like, so on the one hand, the Fed's doing, money policies that may or may not be seen as particularly positive looking. Like, why did the market freeze up? That's not a good sign.
Right.
And yet Bitcoin's fallen.
Yeah. And then like money was created out of thin air.
Yeah, it's
kinda.
like, it doesn't seem make sense. You'd think the price of Bitcoin would go up, but that's the thing. None of these things make sense. So,
Yeah.
but it's interesting. I think it's always good to be aware of what's happening.
Right. And another new one today is for the first time ever, the president of China made a comment that they should seize opportunities to adopt blockchain technology.
Blockchain technology, not so.
They didn't say Bitcoin.
They didn't say
specifically,
Bitcoin, right.
But blockchain.
And again, that could be another case where you have a China coin that's
Yeah.
controlled by the Communist Party and is used to like track everybody's money, and
Which they're already kind of doing.
yeah, and then it's even more controlled and even worse for human rights than the Bitcoin, which is not controlled and better for human rights. So
Right.
you could still have blockchain, and that doesn't necessarily mean it's going to be good.
Yeah.
So,
It's a centralized blockchain.
but it could be good for Bitcoin if they like blockchain. They might like Bitcoin. I don't know.
Yeah. The point is they're getting in.
Yeah, they're getting in. So.
Okay.
I feel like we've said a lot of news items, like in rapid fire. The answer is we don't know.
Yeah. The answer is still regardless of price, there's more buyers than sellers or more sellers than buyers.
And
Simply.
trying to peer into what's happening is
Next
yeah.
one. So Google quantum supremacy.
Okay, so
William.
this is an actual article where we can say actual things.
Yes. This will be interesting.
As opposed to speculation about the future, that's very difficult. So,
Okay.
do you know anything about quantum mechanics?
I just know that they can brute force or decipher things a lot quicker than a normal computer could.
Theoretically.
Okay.
Okay, so everybody knows the kind of the picture you see in every school book, and it's on like an atom, right? You've got a little cluster here of the protons and neutrons. You've got electrons.
Quantum physics.
Yeah, the physics, right?
Okay.
You've got little electrons spinning around this little nucleus.
Right.
That's like the picture you see everywhere, right?
Yes.
It's like a little cluster of balls, look like tennis balls, right? And little balls flying around it.
Yeah.
That's our mental model.
Right.
Turns out that mental model is actually nothing to do with reality.
Okay.
That picture that you were showing in your science book is not the way it is.
Okay.
Electrons and other fundamental particles like that aren't like tennis balls where they're in a specific place. They're actually more like fog or
Yeah.
cloud.
Okay.
So you have your nucleus, which is kind of like this tight little cloud of these things. And then you have electrons that are kind of smeared out all the way around it.
Uh-huh.
And so you want to, where is the electron right now? Well, it's nowhere. It's everywhere, all at the same time.
Yeah, it's pointed like every direction.
It's kind of like a mist almost surrounding. So if you want to figure out, well, where is this mist thicker and where is it not thicker, you can shine light beams through it. Shine a light beam.
Yeah.
And the other thing about quantum, and the reason it's called quantum mechanics, is that these particles, these electrons, can only interact in like bursts. They can only release energy in bursts.
Okay.
So if I shine an electron or a photon or something through to figure out where is this mist, it'll either interact with the electron, in which case it's absorbed and gone,
Yeah.
or it'll pass through. So
Okay.
if I put a film, like a photo film behind, and I'm starting to shine light through this thing to figure out where is the fog thickest, electrons or photons will pass through,
Yeah.
and I'll see it land on the film, and I'll see a dot.
Yeah.
And so the place where the dots are thickest would tell me where the cloud's thinnest, and then the place where the dots don't happen very often
Right.
tells me where the cloud's thickest because it's absorbing it.
Yeah.
So you can shine this, almost like shine a flashlight and kind of get a fuzzy picture of where the cloud is,
Yeah.
but it's not a fuzzy picture, it's actually made of little dots, and where the dots are thicker is where it is.
Yeah. Gotcha.
I don't know if that makes sense.
Yeah.
So anyway, this cloud, the other problem with it is every time it absorbs one of those beams of light,
Right.
it actually destroys it.
Destroys it.
It destroys it, right?
Okay.
Because the light particle at that scale, a scale of an atom, is so powerful, has so much energy. It's like shooting bullets at a statue to figure out
Yeah,
what
so it actually gets destroyed.
just to figure out what, you've got this statue, you're trying to figure out what shape it is. So you shoot a machine gun at it and you look where the bullets land on the wall behind.
That's a good analogy.
But
Okay.
every time a bullet crashes into the statue shatters, so you gotta like
Yeah.
get a new statue and repeat the
You have to
experiment.
do the same experiment again
Yeah.
because it gets destroyed.
Yeah, so that's kind of the concept of quantum mechanics in a nutshell.
Yeah.
So what we realize is because they're kind of fuzzy and foggy, if I have one electron that say represents a 1 or a 0, and I have another electron over here that represents a 1 or a 0, the combination of those can represent 4 different possibilities. The first one could be 1 or 0, while
Yeah.
the second one's true, and then the second one's false, and the first one could be 1 or 0. Yeah,
Right,
4
right.
combinations.
And all opposites, right?
Up or down, on or off, whatever
Yeah.
you want to call it.
Gotcha.
So in classical computing, when we have those possibilities, we say there's 4 different possible states that it can be in.
Mm-hmm.
But because the electrons are fuzzy,
Yeah.
they can actually interact with each other all 4 ways at once.
Yeah.
Like it can be
Especially at the same time.
at the same time, right?
Yes.
So it can be both up and down because it's not quite decided which one it is, and then when they interact,
It's not until they interact, right?
well, as they're interacting, they can be in both places at once.
Gotcha.
Because it's like not here; it's all these places.
Yeah.
So what you can do is, if you get 32 ones and zeros, that's 4 billion combinations.
Okay.
And in a computer, it can be one of those 4 billion.
Yeah.
But the idea is, if we could somehow take 32 electrons and have them all pass through a circuit together as one group,
Yeah.
then you can do all 4 billion computations at once.
In one run, you can do all computations
All
instead
4 billion possibilities. Right. That's the idea behind quantum computers. So that's powerful. If we could do that, we could solve immensely hard problems instantly.
Yeah, but that would also break everything, like our encryption.
Cryptography
Not
and
just
stuff.
Bitcoin, but like all the banking, nuclear
Yeah,
codes.
a
all
lot of
that.
cryptography would be destroyed by this. The problem is, no one's ever managed to send 32 electrons through a circuit all together at the same time.
Yeah.
No one's even gotten close to that.
But in this case,
Except,
Google, I guess?
yeah,
That's
Google.
what we're getting at, right?
Google did the experiment. They actually had 50, I think 53, 54 electrons.
Okay.
I'm not sure if they're electrons or photons or what particle they were using, but they sent 54 elementary particles through a circuit all together at the same time, and they got an answer out.
Wow.
So they actually, by doing that experiment, kind of, the purpose wasn't to actually do anything useful. They weren't breaking cryptography. They weren't factoring numbers. They weren't doing anything that you would consider useful.
So just to see if it would go through. Though.
They were just seeing if they would go through the circuit.
Yeah.
And if they would have some kind of an answer at the other side.
Yeah.
Didn't matter if it was like useful, just to see if it worked at all.
Right.
And that's what they achieved.
Wow.
So it's actually possible to build quantum computers, because before it was always theoretical. We weren't sure if there would be some problem that would prevent it from happening.
Yeah. Wow.
The other thing about the Google experiment is they would send the particles through their circuit, right?
Right.
And then in order to figure out what the answer is, they'd have to measure the cloud that resulted. But every time you measure the cloud, you destroy it.
Just like the statue
yeah.
example. Okay.
Yeah. So the way the Google experiment worked is they would run the experiment, they'd take one measurement, and then they'd destroy the experiment.
Yeah.
They'd run it again, they'd take another measurement, they'd run it again, take another measurement. So they would take millions of measurements, and then the average shape of all those measurements is the answer to the question.
Wow. So the average of that.
The average of all those runs.
Yeah.
And
millions of runs.
Millions, or I'm not sure how many
Or
runs.
whatever,
There's
yeah,
a
X amount
lot
of
of runs,
runs.
right? So that's kind of the shape of the answer.
Right.
So what they were saying is, if you wanted to figure out what shape the answer should, so we got some shape, some random shape of this resulting thing.
Yeah.
If you wanted to sit down and calculate what the shape should look like, right? What would you expect the shape to be for what we set up?
Yeah.
They're saying a normal computer, a normal supercomputer would take 10,000 years to calculate what the shape ought to be.
Yeah, exactly.
Now, that's not useful. We don't care what the shape is. It doesn't solve any real problem. It would just be hard to do.
Yeah, just to generate that shape.
The funny thing is, within an hour of them releasing their article, IBM comes out and says, "Oh, your calculation was wrong. Actually, the world's most powerful supercomputer, which we built, by the way, IBM, can do it in 2.5 days."
Yeah. So it's not 10,000 years,
It's
but 2.5 days.
Yeah.
And then with the quantum one would be 200 seconds or whatever they
Yeah,
said.
yeah.
So it's still a difference of
It's still
noticeably better.
Yeah, it's still better.
Yeah.
But it's not quite as amazingly better as they said it was.
Yeah, because there's a huge gap, 10,000 years to 200 seconds versus 2 days.
Yeah.
Okay.
So it's kind of an interesting little back and forth there. But the point is, if they were to add more electrons or more particles to their calculation, maybe do it with 60 electrons or whatever, then that 2 days, however many electrons they've added, say they've added 6 more electrons, well, that goes into 2 days times 64, so that's like a year.
Yeah.
So now we're getting into, just all they have to do is add electrons, whereas the Google computer, the supercomputer can't possibly keep up.
It gets exponentially harder.
Exponentially
for a
harder,
supercomputer
right? Yeah. So
compared
once
to
you
the
get to like
quantum
100
computer.
quantum qubits, there's no hope. You're just done.
Gotcha.
So they've proven that you can add more bits and make the problem harder.
So once they get into quantum cryptography, could Bitcoin defend itself from that, or like the other regular systems? Banking?
Right. So once we're talking about a quantum computer with 50 bits.
Yeah.
It would probably need several thousand qubits, several thousand electrons all tangled together, passing through the calculation to actually break the kind of cryptography that we're using in Bitcoin.
Okay. So like it's like SHA-256.
Or elliptic curve math that we're using.
Okay.
So Sec P256K1, that's the curve we use. So
Gotcha.
it'll probably take, we're still
far away.
Far away. Right?
Orders of magnitudes away.
Yeah, orders of magnitude. But it's interesting that it's now possible, and this is a real problem versus a theoretical problem.
Yeah, so now it's a real problem now.
So the good news is there's plenty of algorithms out there that are not popular that do resist quantum computers.
Right.
So the oldest one is something called the Merkle signature scheme.
Merkle, yeah.
You've heard that?
I've heard of
Merkle,
I've probably heard you say that actually.
Yeah, and this scheme, the signatures are about a couple hundred K, maybe a megabyte.
Yeah.
So very big signatures, right? You're talking about 1 megabyte Bitcoin blocks. You get one signature per block. Yeah, because they're huge, right?
Yeah.
But they do resist quantum computers because all they use are hash functions, and hash functions aren't susceptible to the kind of parallel computation that quantum electrons can do.
Right.
So we have a solution, right? It's just not very efficient. So what the search is on now for finding more and more efficient variants that would be smaller and smaller, take less space.
Something that's more efficient, and also something that miners, I guess, would agree to move to.
Yeah. So then once we found other algorithms, then now we have to do new blockchains or upgrade our existing blockchains to switch to those new algorithms.
Gotcha.
Yeah. So it's a process.
Well,
Yeah. Anyway,
That's
that's my big rant on quantum computers.
that was a lot of fun. That was eye-opening.
Well, do we have any other news here?
So speaking of some news, there was an issue with the S10 device where
Samsung
unrecognized
S10.
fingerprints could unlock your device, and something to do if you had like a plastic cover and kind of mess up the fingerprint and made it that you could unlock the device as an unrecognized fingerprint.
So the way Edge works, if you have fingerprint login turned on, is we store the private keys to the money in the phone's secure element.
Right.
And then your fingerprint gets read by the sensor, goes down to the secure element, and if it matches, it'll reveal those secrets to the app.
Right.
So if your secure element will reveal the secrets to just anybody,
Yeah, any fingerprint.
that's not good. So if you have an S10, I guess don't use a cover.
Don't use fingerprint.
Don't use, we have PIN login, so you can switch off that little fingerprint login and just use your PIN to log in.
And supposedly they also have some firmware updates to the device that fixes it. So.
Install your updates. That's always a good security hygiene anyway.
Yeah, but speaking of which, I think you covered this last week or maybe a couple of weeks ago. It's probably best to do password only. So in regards to other countries where they're strict, remember they can force you to unlock your device with your face or your fingerprint because it's not protected by the Fifth Amendment.
So in the United States, we have a rule that you can't compel someone to give information that would lead to their being arrested.
Right, you can't incriminate yourself.
Or that's a bad summary of it, but that's kind of the idea.
Yeah, the gist of it.
Yeah. So they can't make me tell my PIN. They can't make me tell my password.
Yes.
So if you use a PIN or a password to log in, the Fifth Amendment protects you. But law enforcement can certainly read your fingerprint because it's just there as part of your body,
Right.
or read your face because it's just there as part of your body. So if you're using those to secure your phone, then the Fifth Amendment won't protect you.
Yeah.
So I personally use my I don't use my fingerprint, but that's just my choice because I'm a little more paranoid than most people.
I'm the same boat with you. So full password all the way.
But I agree that fingerprint's super convenient. So it really depends on that's your trade-off. But on an S10, I would suggest getting that firmware update in place before you re-enable that feature.
Yeah, definitely. Let's see. Another one to drop by on is Compound. I think we talked about it a little bit, possibly.
Brett did an article on our blog, I think, about Compound.
Yeah, and I think it was like on Coinbase also, where so you can earn interest on your DAI or other altcoins with Compound.
There's a few coins they support that they actually have interest-bearing accounts. So if you want to swap your DAI for CDAI, you'll earn a little bit of interest on that.
Yeah, and you're earning interest on the actual coin itself, right?
In crypto, yeah.
Yeah, so if you have Ethereum and you have Compound Ethereum, you're earning X amount of interest on the actual Ethereum coin.
So the way it works is if I swap DAI for CDAI, it doesn't swap one-to-one. Like one DAI might be worth 200 CDAI.
Yeah.
But the amount of CDAI that it's worth is going to actually kind of increase over time. So if I swap back, I'm actually getting a better rate. That's how they issue the interest. They actually by changing the exchange rate between the two.
Got it.
So Compound is very complicated smart contract. I tried to understand it. I understand the interest-bearing part. I don't understand who's paying the interest,
right,
and what their motivation is. But apparently it's working. So if you're interested in that, our next version of the app, we have a blog write-up, and we're going to support that asset in the next version. So
yeah, a bunch of different Compound coins.
Yeah,
including Ethereum.
But if you don't want to wait for our next version, you can go ahead and add those assets right now by just typing in the smart contract address, and you'll have support today.
Yeah, this is going to the custom token scene, and that's where you can add the contract details. Let's see.
Anything else that's cool? Paul is out of town. He's going to be gone over the weekend, and next week he'll be at
Vegas.
Vegas? What's in Vegas?
World CryptoCon. So I'll be out there. Drop by and say hi. There'll be about 4 of us out there. So yeah, swing by. Get some swag gear. And
that's about it.
And Paul will be speaking at the event too. So if you're there,
he's a speaker. What's he speaking on?
I'm not sure actually. We'll have to see and find out.
You can tell that I'm the programmer because I'm not the one who's in on all the
or keeping track of the events.
Yeah. Well, anyway, thanks for listening to us ramble for all that time. I hope you enjoyed our podcast. And remember, store your own keys, your own coins.
Yeah, not your keys, not your coins.
All right.
See you guys.
Okay.
That was cool. The quantum stuff was cool. Yeah. Okay, that caught me by surprise. I thought it was like 200 seconds versus